Hi there, everyone. My name is Dominique Intriego, and today I'm going to be talking about Experiment 9, Acid and Base Titration 1. So first of all, I want to give some definitions and a little bit of an introduction. I want to compare and contrast analyte and titrant. The analyte, which is going to be located in the Erlenmeyer flask, is an acid and has an unknown concentration of hydrogen plus ions, and the titrant, located in the burette, is the known concentration of hydroxide minus ions. Now, the equivalence point when performing a titration, the titrant is added to the analyte until an equivalence point is reached. The equivalence point is when the amount of titrant added is enough to completely neutralize the analyte, meaning that the moles of acid are equivalent to the moles of base. The endpoint is when the indicator changes color in an acid-base titration, and here are some pictures to help you fully understand what I'm talking about. Now, the difference between the endpoint and the equivalence point is that the equivalence point is when the moles of hydrogen plus ions equals the moles of the hydroxide minus ions, and the endpoint is when the indicator changes color, meaning that it's past the equivalence point. Our indicator in this experiment is called the phenolphthalein. It's a molecule which purpose is to approximate the equivalence point by turning it into a different color when its pH is close to the pH of the equivalence point. And here's a chart to fully help you understand what I'm talking about. Now, the chemicals that we're going to be using today is potassium hydrogen phthalate. We're also going to be using sodium hydroxide and obviously our phenolphthalein, which is our colorless pink solution. The materials that we're going to be using today is a balance, 3 Erlenmeyer flask, deionized water, volumetric pipette in the pipette bulb, 2 beakers, distilled water, burette and burette clamp, and finally we're going to be using a stem glass funnel. So for part A, the preparation of primary standard, in this experiment we'll perform this in 3 trials. So we're going to measure the KHP and record our mass. Make sure you have 0.3 grams approximately. Then we're going to place it in the sample in the 250 milliliter Erlenmeyer flask. We're going to add 50 milliliters of deionized water with a volumetric pipette and pipette bulb. And we're going to label the flask to identify the sample. Then for part B, the preparation of secondary standard, we're going to be measuring 2.0 grams of sodium hydroxide. Then we're going to place the sodium hydroxide in a 1,000 milliliter beaker. And after that, we're going to add 500 milliliters of distilled water. And we're going to stir to dissolve the sodium hydroxide. And then this would be approximately 0.1 molarity sodium hydroxide. For part C, the preparation of the burette, we're going to put the burette in the burette clamp. We're going to place the stem glass funnel on top and pour a small amount of sodium hydroxide to rinse it. Then we're going to use a designated waste beaker to empty the solution through the stopcock, and we're going to repeat this process twice. After rinsing the burette, we're going to fill it with new sodium hydroxide, and then just make sure you do not overfill it. And if it just so happens that any bubbles appear, just gently tap the burette with your finger, and then we're going to record the volume reading. For part D, the standardization titration, which is how we perform the titration, we're going to add 2 to 3 drops of phenolphthalein indicator to Erlenmeyer flask, and we're going to swirl it. Then we're going to add the sodium hydroxide from burette to Erlenmeyer flask and swirl it. After that, when the indicator starts changing color, we're going to add less of the sodium hydroxide. And then we're going to record the volume reading of the burette of the sodium hydroxide. And after that, we have to repeat if we happen to have enough solution left. And one thing that is really, really important about this experiment is that we do not go below the 50 milliliter mark if we would like to perform another titration. Thank you so much for watching. I hope this was really helpful, and I'll see you next time.